This is Mr. Beck Does Your Homework, Homework 22, questions 8 through 11. A series combination of two resistors, 8.51 ohms and 4.51 ohms, is connected to a 9-volt battery. Calculate the equivalent resistance of the circuit. So I have a battery and I have two resistors. This one is 8.51 ohms. This one is 4.51 ohms. I know that my total equivalent resistance, my Req, my equivalent or my R total, is going to be the first resistor plus the second resistor because they're in series. That's how I add resistors in series. So for me, that's going to be 8.51 plus 4.51, which is going to give me 13.02, I guess, ohms of resistance. So that is my equivalent resistance of the circuit. For question 9, it says calculate the current in the circuit. Well, I can treat this, since this is 9 volts, I can treat this also as a 9-volt battery and a single 13.02 ohm resistor. My equivalent resistance here is this single resistor. So now if I want the current in the circuit, well, that's the current leaving the battery. It's going to be the same as the current flowing here. It's going to be the same as the current returning, and that is going to be, through Ohm's law, I equals V over R. So for me, it would be 9 volts divided by 13.02, and that's going to give me my current flowing around the circuit. Question number 10 says, what is the potential difference across the 8.51 ohm resistor? So now I know my current. This current leaving the battery here is going to be the same as the current leaving the battery here. Is going to be the same as the current flowing through this resistor. So if I want the potential difference, or the voltage of this resistor, I'm going to do the voltage of that resistor is going to be the current through that resistor times the resistance of that resistor. So the voltage across that resistor is going to be the current that I just figured out up here times the resistance of that resistor is going to be 8.51. So this is using Ohm's law for a single resistor. So this current, which is the current of the circuit, which is also the current through the resistor, IR will give me the voltage drop there. So that will give me my voltage drop across that resistor. Question number 11 says, what is the potential difference or voltage drop across the 4.51 ohm resistor? So now I want this one. Now what's neat here is I could do the same thing and do I times 4.51. So I could do V equals I times 4.51. That would give me an answer. But what I also could do is take this V and subtract it from 9. So 9 minus this one, I'll call that V1 for this resistor, and this is going to be V2, the voltage across that resistor. So 9 minus V1 is going to be V2, because these two resistors have to have the voltage add up to the total voltage. So if I went down part of 9, I'm going to go down the rest of 9. So this would be a good way to confirm that that number is going to be a right answer, because this one plus that one have to equal 9 total for me, 9 volts total. But you could calculate it either way.